Okay, so I'm going to go ahead and go over the notes because I kind of just posted them for you guys to copy. And we're going to go over them so that they make a little bit of sense just in case you're a little confused. So we're going to be going over parent functions. So a parent function is the most basic function that you have. For example, here we have y equals c. That is just going to be a straight line. Now, in this case, we had to use a number. So it can be any number that you want. We use c equals 2 just for the sake of the example, but it could equal to 3, 4, 5, 6, 7, whatever it is. So your domain is going to go from negative infinity to positive infinity, and then your y value is only going to be one number because it is constant. Okay, and then there's a little table just to match up with your values. Your linear function, which I know you guys are most familiar with, is y equal to x. Now the slopes do vary and your y-intercept varies, but the most basic linear function is the y equal to x line. And your domain is going to be all real numbers, and so is your range. And we have our next one, which I know you should be familiar with, which is your quadratic function. So your quadratic function is your y equals x squared. The shape of your graph is this little U shape. And your domain is going to be all real numbers from negative infinity to positive infinity. But your range, you don't see your graph fall below 0. Okay, and then it goes up forever and ever to infinity. The next one is going to be the square root function. So y equals the square root of x. Now this is what your graph looks like. You cannot take a square root of a negative number, which is why we have these errors when it comes to -2 and -1. Okay, your domain is going to be from 0 to infinity, and so is your range. Now you have your absolute value function. So on your absolute value function, your graph looks like this V shape. It does not go below 0, so your range is going to be from 0 to infinity, but your x values can be any number between negative infinity and positive infinity. And this is what your parent function looks like for your absolute value. Y equals absolute value of x. Your cubic equation is y equals x to the third power. So y equals x to the third power looks like a little snake shape. So it starts down here, it kind of loops up, and then it goes up forever and ever. So your domain and your range are both negative infinity to positive infinity. So it covers all real numbers. Your rational function. So on your rational function, your denominator is equal to 0. Your denominator cannot equal to 0, which is why, for example, here your graph starts on the left, and then as soon as it gets close to 0, it shoots down because it does not want to cross 0. And then the same thing on the other side, it comes straight down until it goes a little bit further out because it does not want to get close to 0. So that's why you have this little gap here where we have to put a little u in between, and we have to put the parentheses on the 0, is because your graphic gets really close to 0 but never crosses. And whenever x is 0, that makes it undefined. All right, your next is going to be your exponential function, which is y equals a to the x power, where a is any number. So for the example, we use 2 to the x power, and your graph just slowly rises. Your domain is from negative infinity to positive infinity, and your range, your y values, do not drop below. So if you notice, you don't see your graph anywhere down here, and it does not fall below the x-axis. All right, your log equation is the opposite of exponential. So because it's the opposite of exponential, your graph is going to look a little bit different, kind of the same idea. Now your domain and your range are opposites here because they're opposite, or they're inverses of each other. And then this is what your equation looks like. Now your base can be any number. In this case, we use log base 2. All right, so we're going to look at a few problems on your assignment. That way you know exactly what to do. I'm going to go ahead and do a few of the even numbers, and you guys would finish off the rest of the even that I don't do, and then along with all of the odd numbers. So if we look here on number 2, they're asking us to give the name of the parent function. So we're just naming the parent function. So if we look here, g of x equals x to the third power minus 2. This third power gives us a hint that makes it a cubic equation, because your cubic equations are to the third power. So I'm going to go ahead and write here cubic. Okay, the next one. Here we have 1 over x plus 6. So 1 over x plus 6, because we have a fraction here, that is my biggest hint that this is a rational function. Rational. The next one says log base 3. So right away we see a log. That's a log function. Log function. And I'm going to abbreviate function also. All right, the next one. Here we have x squared and we have x. So because we have both of them, it doesn't make it a linear and a quadratic at the same time. You look for the highest exponent. So the highest exponent is to the second power. So that's going to make this a quadratic function. Quadratic. And then the last one, we have 3x plus 1. Because we have the x there, that makes this a linear function. Linear. All right, this next part wants us to sketch the graph of the parent functions, okay? So if we see on number 12, we see these two lines here, that means the absolute value. So if we refer back to our notes, our absolute value, our function is this V shape, and it looks like this. That's all I want. I don't want this equation specifically. We want the parent function, and this is what the parent function looks like. All right, the next one is 5 to the x plus 1. Let me write absolute right here. Absolute. This one is going to be, the next one is your exponential function. Exponential, EXP. Okay, and your exponential functions look something like this. And that's because the x is in the exponent. Okay, it's the exponent of 5 to the power of x plus 1. So that's how we know this is exponential. All right, this next one now, I do see a squared out here and the x is inside there. So that is going to give us an x squared, which is going to make this a quadratic function. Quadratic. Okay, and the next one, it says, give an example of an equation represented by the following family of functions. Do not use any of the equations used in 1 through 16. So you need to make up your own. You can't use the ones that they just gave us. So we need to give an example of a square root function. So I'm going to put f of x equals the square root, and then we're going to make up numbers. X, oh, no, it's not right. X minus 1. And we put that in the square root. That's an example of a square root function. A rational. Rational means that it's going to have a fraction in there. So we're going to do f of x equals 1 over, and I'm not just going to put x, I'm going to have to add something. So I'm going to put x, oh, it's not writing, x minus 3. Okay. And that's just an example of a rational function. All right, here, just by looking at the graphs, we have to name the parent function. So I'm going to do 23, 26, and 29. So 23 looks like this V shape. Whenever you have a V shape, that is your absolute value. Absolute value. Okay, and we're matching this up to the ones on your notes. On the next one, this one, it starts here, and then all of a sudden it shoots up. And this one right here was pointing straight down, and then it goes across. That is your rational function. Rational. All right, the next one. This one starts at this point and it goes on. Now, if you look at your notes, this looks like your square root function. Square root. All right, the next one says, give the name of the following parent functions and give their domain and their range. So this one also is a square root function. It starts at one point and then it goes on. So the name is square root. And then your domain is going to start at 0. It does start at 0, it touches, so it's going to be a bracket. It goes to positive infinity. That's going to be your domain. And then your range, it also starts at 0, and it goes up very slowly to positive infinity. So from 0 to infinity. And that's it. The rest is for you guys to work out on your own. Make sure you guys turn this in. You should also have enough time to finish your bubble maps from yesterday. We'll see you guys on Monday. Bye.